Okay. Welcome, everybody, back to the Active House podcast. Everybody's laughing because we had a little bit of a technical glitch just a second ago, but we got it fixed, and we are here with the Active House USA podcast, where we're going to be talking about Active House. Active House is a global philosophy. You call it. I call it, or David Knight called it a philosophy. I refer to it as a movement, but it's been going on for 10 years, a platform. Active House is healthy buildings for people and planet. Okay, Active House is healthy buildings for people and planet. Active House is being practiced in 21 countries. There's a whole list of countries here that are practicing Active House. And I just want to sort of refresh people's memories that Active House is about it's focused on the comfort of the person who is either living or working or just being inside of a home or an office building or any kind of a building. Active House has these 9 principles that break out into 3 different main categories. We've got comfort, which I think is one of the primaries. I mean, I guess they all are, but comfort breaks out into daylight, thermal environment, indoor air quality, and acoustic quality. And then we've got energy, which breaks out into energy demand, primary energy performance, and energy supply. And then we've got environment, which is sustainable construction and freshwater consumption. Today, we are going to be focusing specifically on indoor air quality. And my name is Brian Bernasconi. I am a real estate broker with Christie's Sereno in Silicon Valley. I started a conversation with the folks here at Masana and was immediately just enthralled with the topic. I know I sound like a dork, but I mean, I'm just so in. I know you guys love this topic too, right? The whole Active House concept, because in my world, people just remodel houses and they rebuild houses and they build houses, and I don't think they put that much thought into the Active House principles, which is why Active House exists. That's why it's coming up and people are paying attention to it. Alessandro here with Masana Hydronic Technologies. You're hosting us as well. We're at your office here in SoCal, California. I've got over here Ryan Knight from Monterey Energy Group. And Ryan, give us the brief overview of who you are and what you do.
That's right. I'm Ryan Knight with Monterey Energy Group, and Monterey Energy Group is also helping to usher Active House USA into USA. Active House has existed in Europe for about 10 years in 21 different countries, and here in the United States, there are a bunch of different home rating systems, LEED, Passive House. They're all fine. What we love about Active House is that it really focuses on the human felt and sensed environment while balancing all of these other sustainability design features.
Yeah, got it. And Alessandro, I didn't mean to skip over you. What does Masana do?
We are a company that started the technology of radiant cooling here in the US, and now we became like a hydronic technology player. So we do anything related to hydronic systems, so radiant cooling, controls, air treatment unit for air quality, and so on.
People have been, I don't know why, it's the coincidence, but people keep asking me recently, what's the best choice for heating your house? And
Radiant.
I've been radiant.
Radiant.
I mean, it really is. When you start to learn about it, it really is. This forced air stuff is for the birds. It's like, I didn't realize.
It used to be just radiant heating. Now with radiant cooling, you can do just everything through a radiant system.
Yeah, and you get more control, you get more comfort. I mean, we'll talk about that at another time. And then to my right, I've got Scott Gottesman, who is here with Panasonic. Yep. And you are with the Indoor Air Quality Division of North America?
North America, correct. We are the Ecosystems Division of Panasonic, North America, and I am part of the Indoor Air Quality Division. So we focus mainly on indoor air quality and moisture control.
Okay. Indoor air quality and moisture control. And that's, I mean, we've been talking a little bit today. That whole moisture control part is really something that you guys are, when you say it, do you say it in those 2 parts like that?
Typically just IAQ, indoor air quality.
Indoor air quality, but that includes humidity, and we'll get to that in a minute.
Sure.
Okay. So just to give Scott a moment here, tell me, because you and I met at this trade show, the
PCBC, the Pacific Coast Builder Show.
Thank you.
You're welcome.
I was up there. We made a video. You can go check that out on online. The video that we made about that trade show. But you were there demonstrating to me what Panasonic builds. And so, can you give a description of what that is?
Yeah. So the product that we looked at PCBC was the ERV, and that's an energy recovery ventilator. And what that does is it actually exchanges outside air with inside air with inside air. And what we do is we temper that outside air with the inside air, reducing the energy load and still creating that air exchange within the envelope of that home.
Okay, let's get down a little bit further on that, because I saw the things. These are basically like boxes that have blower units in them or fans in them, right?
So we have ECM DC motors in our products, and within that unit we also have a MERV 13 filter. So we're filtering the air before it actually gets into the envelope, and we also have an empathy core in there that helps temper the air as it flows through the inflow and the outflow of that air. So we're able to help recover anywhere from 72 to 82% of that energy that's getting lost if you were just bringing in hot air on a summer day into your air-conditioned home. That would raise that energy load up because we're just trying to keep up with the hot air and trying to cool our home. Likewise, in the winter, if we're pulling cold air in and we're trying to heat our home, then we're able to temper that air as the streams cross within the ERV and dumping that fresh air into the house.
Got it. Did that make sense to you guys?
It does.
You were following all that?
Yeah.
Can you summarize that for me?
Yeah, so I just want to go...
Because it got a little technical for me as well. I mean, he's using some jargon in there.
Yeah, one step back. So why mechanical ventilation has been introduced in our building? So what is happening is that we're building houses that are tighter and tighter. So
right,
it's
tighter envelopes, because you used the term envelope. The envelope is
yeah.
is basically the
shell of the
Yes.
house.
Yeah.
Yeah.
So a house needs to be neutral pressure. Okay, so you cannot have if you pressurize the house, then the air will go out, or if you depressure, then air goes in. So a house needs to be neutral pressure. And in the past, when we didn't use the mechanical ventilation, so basically the house was breathing by himself. So
yes.
Somehow air escapes, like hot air goes up, and then you find an escape from cracks, from the house not being well sealed, right?
Yeah.
And so if air goes out, then fresh air goes in. Okay, and the ventilation was just based on this breathing, natural breathing, and opening up the windows. Okay, so what's wrong with that? Well, first of all, air going through all these cracks can actually catch pollution and VOC, which are volatile organic compounds, based on the material that was used to build the house. So it's not a healthy air.
So air coming in through these cracks brings with it pollutants possibly, or like we talked about smoke in the summertime here, maybe in California, or pollution from nearby traffic,
yes.
or air traffic, or pollen and dust.
Even exchanging air with the material that was used to build the house. So
yeah.
Who knows compounds within the envelope of the house are classically super toxic, things like that.
Got it.
And before the introduction of balanced ventilation and ERVs, we relied on things like whole house fans or even just bath fans. And those would create a negative pressure environment into the house, which then would allow air to infiltrate through the porous areas of the home. These days, we're building homes really tight. Why? Because we prevent energy consumption. We lessen our heating and cooling loads. We make the house more comfortable. And that just requires balanced ventilation, a constant stream of fresh air being introduced to the space while the same amount of air is being pulled out of the space.
Right.
Yeah.
And so with a product like what Panasonic is providing, it's not just pushing air in out of a fan. It's not just blowing fresh air in from the outside.
You control.
You control the air coming in, and you balance the air that is coming from the outside with the air that's already on the inside.
And even better, if it's 90 degrees outside, which would be an uncomfortable temperature inside, when the inside air is exchanged with the incoming outside air, it actually exchanges that heat. And so it preconditions the air. So we're not just dumping 90-degree air into the house, which is going to create a big load on your air conditioner. It's going to be preconditioned. Maybe there's a delta T of 5 or 10, which keeps us nice and efficient.
How does it precondition it?
Well, there is an energy core within this unit. And so as the incoming air passes through that stream, the outgoing air also passes through that stream, and it captures the energy from the conditioned inside air and passes it in.
Okay, got it.
It's a heat exchanger.
Got it. Yeah. Which most people don't know what that is either. So, do you want to explain what a heat exchanger is?
A heat exchanger it's a way to exchange energy. So you have air going in, air going out. You create a barrier between the air going in and air going out, and through this barrier there will be some exchange, meaning that if you have cold air going in, it will get this, let's say there is a layer and like a metal layer, or now they will use other material, but you get that metal layer to be cold, and the air coming in that is warm in touch with this cold layer will get colder.
Yeah.
And so now if this barrier is done in a way that there is a lot of exchange, so you increase this surface where the air will be exchanging, then you get a very high efficiency. So like HRV, they can go up to 90 and more percent heat exchange. So it's very energy efficient to do that. So
which translates to people like me, homeowners anyway, that our energy bills would be potentially decreased by using this type of technology.
Yeah, it's not just dumping out the air, but before you dump it out, you try to suck all the energy that has been invested in treating this air, in cooling the air or heating the air.
Yeah. Okay, I'm getting that. It's sort of like regenerative braking in a way, right? Like you're going to be using that inertia. Is that a good analogy?
That's a great analogy.
Yeah, I'm using that inertia to capture the energy and recycle it back into the car.
Before dumping it out.
Yeah,
because everybody knows about EVs these days.
Right? I think, I don't know, maybe in California we do, because every third person drives a freaking Tesla.
That's right.
Okay, so what I want to, the thing I've learned from you guys about air quality, that I just want to emphasize for the audience is, it's something that we don't think about, and just opening a window or having mechanical windows that open is very different than having this type of air exchange technology. Did we talk? We haven't talked a little bit, but the units are not huge. I mean, these aren't like air conditioning units.
No. And there's different sizes. Every manufacturer makes like a good, better, best size product for whatever size of the home that you're trying to outfit with the ERV. Some can be anywhere from 9 inches thick to 36 to 48 inches long. Others can be a little bit more bulkier. But whatever product's going to fit that project is going to be sized right for it.
And the bulk basically depends on the amount of space you're trying to condition.
Correct, yeah.
Yeah. And for my sake, I always like to break it down because I'm on more of the consumer side. I know you guys are more on the contractor side, but just so people know, on the consumer side, what kind of cost range are we talking about for these units?
Well, the cost range will really depend on the size of the home. You've got anywhere from a 2,000 to 10,000 square foot house. The equipment will need to be sized, and I think you could probably expect anywhere between a $3,000 to $7,000 quote for something like that.
Does that include installation?
That would include your equipment and installation. Yes.
Okay. And of course, don't quote us on that. That's ballpark stuff. So don't come running to one of us and saying that we misquoted it. But I'm curious, you said home. Are you saying home because I'm in residential real estate, or do you mean home or office or whatever application?
The size of the equipment, they make residential equipment, ERVs, and then they make commercial size ERVs. So Panasonic, our brand, we specifically focus on residential.
Okay. Oh, you guys do. Okay. But the same technology can be and is being applied into commercial buildings as well.
Yes. Probably the other way around. It was originally in the commercial spaces, and now we do mechanical ventilation
for residential.
That's right, because in commercial we've got bigger buildings,
or people,
more human-intensive activities going on,
and windows that don't open.
Windows that don't open, exactly.
Yeah, right.
Exactly.
So you've got to bring air into the building.
That's right.
Got it.
And the same concepts apply. Hey, in a commercial space, we want to be good, productive workers. We want to be energetic. We want to be clear-headed. And indoor air quality relates to all these components, all these features. In Active House, we're really focused on the human living condition. And, we're in the world of not just being healthy, but being high performers and expanding our health span and preventing COVID from getting in the house and all those things. Indoor air quality is a primary gate or a primary method to enhance all these features.
Yeah. No, I mean, from everything I've been learning through you guys and others, Alessandro and Francesco, and I mean, this idea of indoor air quality, I think, has been largely just overlooked by people. And maybe here in California or in Northern California, we have cleaner air, but it's still not perfectly clean, depending especially on where you live, if there's air traffic or auto traffic or, like we said, pollen or wildfire smoke.
Yeah. And we spend most of the time at home.
And
so
yeah.
That's also key.
Yeah, you spend about anywhere between 70 and 90% of your time indoors.
Yeah, wow.
Yeah. And most people don't think about it that way, but you think about the hours that you have slept overnight. You've prepared to get ready to leave for the day. And there's really only 8 of those hours that are dedicated away from your home if you're working full time.
Right. And the systems that we're talking about, this is a round the clock system. This isn't just, I mean, it might know, and we'll talk about this in a second, but I know there's technology, and this is the probably the worst example I could give, but like the thermometer, that has a sensor as to when people are moving around or whatnot, right?
Yeah, there is equivalent technology for indoor air quality, which basically a basic indoor air quality system will run 24 hours.
Right. So even when you're sleeping, it's
continuous.
There are some
when you're not home.
Or when you're not home, yeah. So it's prepped for you when you get home.
Yeah. However, we can do something better, and so we are talking about indoor air quality and how you can control it if you don't measure it. So now there are technology available to measure the quality of the air.
Yeah.
And so this is an example. This is an M-Sense sensor. We call it comfort sensor, and measure a few things. It measure the through this ring here, it measures the operative temperature, and there are some opening for the air to go in, and we measure the air humidity and the air temperature, and there is also, it's called VOC sensor. It's a sensor that measures the volatile compound, organic compounds in the air, in the form of gas. So these VOC are just particles that are in the air coming from can be from anything, from outdoor sources or even like walls or construction material that has been
off-gassing of new construction materials, the mattress you just bought that got delivered to your house,
right?
The brand new carpet you just had put in your home,
right? This off-gassing concept, I think people know about, and so that unit would be able to measure those particles.
Yeah, this is the basic technology that has been used in commercial building will be measuring the CO2. The CO2 tells you how much dioxide carbon is in the air. Typically, right now, 4 of us doing this podcast, we're breathing and then we're dumping CO2 in the air, and so you want to ventilate, right? That was the basic science for controlling the ventilation in commercial buildings. Sensor for CO2 are expensive, needs to be calibrated, and so to put it in a house would be a little bit more complicated. But now Internet of Things come with this new technology sensor that are cheaper, low cost. Like a sensor like this would be like $200. You can find $400 a Wi-Fi sensor that will measure your VOC, indoor air quality. And so based on this measurement now, we can decide when and how much air we want to exchange. Because if the VOC goes too high, means that the air quality is bad in the house, and so we need to either boost the ERV system or to activate the ERV system, or to do other technology. There are also like natural ventilation. I mean, in some cases, still opening a mechanic window can also be a good strategy,
Right.
if the outdoor condition allows it. So
Let me see that sensor for just 1 second. I just want to. But really, when you have this sensor in your house, all you're going to see is that part there.
You only
I'm
see
thinking
that.
about my wife. She's going to be like, "That's ugly."
Yeah.
But really,
No,
what you're going to
it's,
see is just this little puck.
There is this sleeves that will be screwing the drywall.
Yep.
Can I have
Yeah,
it
yeah,
back? And then so this will be flashed with the drywall, and then you just push it in.
And it just sits, and you
then-
just see a little bit of it, because I know
Yeah,
you guys
you-
have them here at the office, and you don't even notice
You just
them.
see this. This
There's
little
one over on the
plug,
wall right there.
Yeah, just to have some air to go through.
Right, and then that plugs in, and so in, let's say, a 3,000 square foot house, how many of those would you need in order to balance out the?
We use this sensor not only for the air quality, but also for the humidity, which, as Scott was mentioning, is part of the air quality.
Right.
Controlling
Let's
the
talk
humidity.
about that.
Yeah, so we, because in Messana we specialize in radiant cooling system, we want to measure the air quality in every single room. So we will use one sensor for every single room of the house. And so we have a map of humidity, temperature, and VOC in any room, and so that dictate what the control system will do.
Okay.
So either we need to exchange more air, so get more fresh air, or activate a radiant system to control the temperature.
And these sensors here, you can integrate them with the system that Panasonic or other vendors are.
Any ERV or HRV technology, we, based on the measurement, we have different logics to boost the Panasonic ERV, or to activate a ERV or HRV system.
Will you do me a favor one more time? Tell me what ERV is.
ERV is energy
Recovery ventilation.
Recovery ventilation.
ERV is
And
energy recovery ventilation. And HRV
HRV is heat recovery.
Okay.
It's a little bit. So the big difference between ERV and HRV is referred to the humidity. So HRV it's will let the humidity to come in and go out. Like ERV somehow it's more like of a barrier for the humidity. Humidity not going in and not going out. ERV are becoming popular also because they don't need any condensate drain to be installed. That makes it very make it easier to install, because an HRV, because has a very high efficiency in exchanging with temperature efficiency, like heat exchanging, then it will be condensation on the core, and so you need to add a condensate line, which makes the installation more expensive.
In your practice, which one of these two are you installing more frequently? Is it predominantly one or the other?
In California, currently, we're predominantly installing ERVs because we have perfect humidity here for the most part.
Got it.
Our business, Monterey Energy Group, really focuses on very high-end homes within a couple miles of the coast. I mean, we're all over the place, but so in those conditions, there's some design philosophy arguments in that world, but generally speaking, we're installing ERVs.
If you're right on the coast, don't you get humidity? Isn't fog humidity?
It is, but
it's not the same.
It's not the same.
Yeah, and it comes and goes.
It comes and goes. Generally speaking, we're at 50%.
And
when we talk about humidity, we have to kind of think about Midwest, East Coast, and how they experience humidity versus California.
Right.
Our air's a little drier. It dries out a little quicker. We might get fog. where they get temperature differences
Right.
and sandwiches from the Delta. That's, where you get the big difference between West Coast, East Coast.
Yeah.
I wanted to relate these sensors back to the active house philosophy because you talked about good, better, best solutions from you manufacturers. Well, in the design philosophy world, we have the same thing, and active house scores them, says one's better than the other, and sensors are better than no sensors. If we're just providing balanced ventilation via the ERV or HRV, that's good. But it may have a perverse effect on the total energy consumption of the home, which would then give you a lower score in that energy demand category of active house. So with sensors, we can actually compress the amount of outside air to just the bare minimum of what's needed to stay within these very healthy indoor air quality bands. Also reduce the amount of heating or cooling power needed to keep the facility comfortable. And then there are a couple of other design features like how you actually locate registers. We talk about displacement ventilation, where you supply your fresh air down low because CO2 is actually heavier than air and it will sink down. So if we provide that stream of air down low and our return way up high, you can imagine the CO2 raising through, getting filtered out, and exhausted to atmosphere.
Yeah. Okay. So, I feel we're getting out of time here, but Scott, I want to just make sure. I've heard you talk, and you go on and on. You love this subject, right?
I do.
You're very knowledgeable.
I'm very passionate about it.
And so, regarding indoor air quality, can you just give me sort of your take on what the most important points are?
Well, the most important part is noticing it, addressing it.
What's it?
The indoor air quality. If your family has high allergens and they're having a hard time breathing, that could be an indoor air quality issue that you're not really addressing, but we're throwing medication at it. So if we look at our homes as a place where we actually live in, could that be part of that problem? And so indoor air quality has become such a big focus, not just from the consumers, but it's the builders and what they're going to start offering. And just because of what has happened over the last couple of years with COVID, indoor air quality has certainly been one of those things that even the CDC has been talking about, and having good air exchange in the homes. And as we've talked before, as these envelopes get tighter and tighter, less leakage air in, we're going to need a more filtered air exchange in the homes for better living, better health, and breathe easier.
And starting that at earlier on in the phase. I mean, for the amount of cost that we're talking about, I just think that it seems like more people should be incorporating this type of technology into building. And again, this is why Active House exists, because we want to sort of get the word out that the comfort and health of the inhabitants of the building is important, and you can get ahead of that a little bit by incorporating some of these principles and thinking just a little bit downboard about what technologies can we apply for really incremental cost, or at least have the offering. And this was something I think that David made was, have this unique offering for the builders out there, to be able to say to the consumer, we've built these homes with these specs according to this philosophy or these principles,
guidelines,
these guidelines
to build a better,
and be able to point to say, hey, we've been working with these Active House principles. I think would give you differentiation as to what you're offering to the consumer.
You can measure them and monitor them over time.
Right.
Prove it.
Yeah, and good air exchange and good indoor air quality is a lot cheaper than medical bills.
For sure. No, and I mean, way less painful, really, in a way. I mean, it makes total sense. Again, this is the Active House Podcast. We appreciate you guys coming in. We're going to be talking about these principles and Active House and this philosophy more in future podcasts. So please come back. If you want to learn more, go to activehouseusa.org. You can go in there and read about the principles and the Active House movement or philosophy. And there's contact there. If you want to talk to anybody from Active House, you can get in touch with them to learn more. And then please come back here and listen to the next podcast. We good for the moment? You good?
We're great.
Thank you
very
for
much.
coming in, Ryan. I
Thank
appreciate
you.
it. Thanks for coming in, Scott. I
You're
appreciate
welcome.
it.
Thank you for
All
having
right.
me.
Thank you.